Welcome friends. In today's lesson we're going to break down the following limit using power series. The limit that we have is here. That's the ln of this whole function, and we have two sine function. This is sine, this is sine over x to the power 3 as the limit as x approaches 0. So the first thing is first, we are going to deal with these two boys separately. I'm going first to deal with the first part, then I'll deal with the second part, then at the end I'll come and add them. So let's dive in. Let's start doing the first part. The natural log of 1 plus x over x squared minus x plus 1. Now before we start solving this, I want to show you some simple algebra, and basic mathematics, combining indices. So I'm going to do one thing. I'll say h over b, the first thing. Then another thing I will do is a to the power b plus c. So then also for this one, let me introduce natural log. Ladies and gentlemen, I want to tell you that natural log of h over b, it is the same as natural log of h less natural log of b. It is this statement. For this one, you can break it down as this. You're going to, since the base is the same and the powers are adding, you are going to write the base with one power multiplied by the base with another power. This we have used the indices, this we have used the properties of natural log. And again, natural log of, if it was h multiplied by b, like this is the same as natural log of b plus natural log of h, which is just the same as natural log of h plus the natural log of b. Now, since us knowing these facts, let's come and deal with this individual here. So we have the natural log of 1 plus x over x to the power x minus x to the power x plus 1. Now you have to ask yourself a question. Since we are having the powers, two powers with one base, we can separate. We can give x the power of x multiplied when x has the power of what? Of 1. Let's do that in our first step. Our first step, we have identified that we are going to maintain everything the way it is. We have x to the power x less x to the power x multiplied by x to the power 1. In our second step, we have to see our denominator. Our denominator now has x to the power x for this value and x to the power x for this value. So we can factor out x to the power x. So in our step 3, we are going to factor out x to the power x. So this is over x to the power x. I have a bracket. This will be 1 less x, like this. Now, what we can see is this x, we can pull it out altogether so that we come up with something like this in our following step. We have 1 over x to the power x multiplied by 1 plus x over 1 minus x. So now, what we have, we can apply the properties of natural log. When two functions, this and this is multiplying, we are going to allocate a natural log to this function, then plus when we allocate a natural log to this function. Let's go ahead. In our following step, we have natural log of 1 over x to the power x, then plus natural log of 1 plus x over 1 minus x. Now remember of what natural log does when you have two functions which are dividing inside. They can be natural log of this function minus the natural log of the bottom function. Let's go ahead. We have natural log of. Now look at how I'm going to rewrite this. We know that, let me come here and show you one thing. We know that 1 over x can be written as x to the power negative 1. So we are going to use this fact there on how we are going to rewrite this. We are going to take it on top, and we are just going to add negative to the power. We're going to multiply the power with a negative because we know that this means inverse. Then plus the natural log. Now I'm going to get this function alone, which is 1 plus x. Then we are going to say less this function with natural log, less natural log of 1 minus x. Ladies and gentlemen, this thing which we have here is the same as that. Now in this form, it is easier for us because we can find we can find the power series representation for this function, and you can find the power series representation for this function and for this function. Then we are going to add this power representation plus this, then minus this power representation. That's what we are going to do. So let's go ahead and let's dive in. Now look, for our first function, we have x to the power negative x. Now we know the properties of natural log and how they behave. Natural log drops the power, this power, to multiply with the whole function. So what we are going to have is negative x, this boy multiplied by this. Now you have to ask yourself a question. What is the power series representation for natural log of x? In our previous videos, in our previous marathons, I did show you how to find the power series representation for natural log of x. So I'll just go ahead and write the power series representation of natural log. So we have negative x. We have negative x multiplying with the power series representation of natural log of x, which is sigma infinite n equal to 0. N equal to 0. We have negative 1 to the power n, x less 1 to the power n plus 1, all over n plus 1. This is what we have. This is what we have for this function. So for this one, we are going to multiply with this. Then we are going to add it. We're going to add it. We're going to add this for this guy with the power series representation for natural log of 1 plus x. Now we have to find the power series representation of natural log of 1 plus x. 1 plus x. The easiest way for us to find the power series representation of natural log of 1 plus x, let me name this our first part as 1. Then let's find for this boy. So I know that natural log of 1 plus x, if I differentiate this, it's the same, it will give me 1 over 1 plus x. Now I just need to convert this in the form of a over 1 minus x. We can see that what we just required is for us to separate the negative. So I'll have 1 over 1 less negative x. So this is still the same. So what we are going to have, we're going to have negative x to the power n, and what we are going to have is negative 1 to the power n, following the videos we did yesterday. Now this what we have, it is for this. So for us to find a power series representation for natural log of 1 plus x, we just have to integrate this. So when we integrate it, we are going to have the series infinite n equal to 0, negative 1 to the power n, x to the power n. Then we are going to add 1 to the power, and we are going to divide by the new power. we're going to divide by the new power, which is 1. So this here is the power series representation of natural log of 1 plus x. 1 plus x. So this is what we are adding to this boy. So we are adding infinite n equal to 0, negative 1 to the power n, x to the power n plus 1 over n plus 1. Now, we also have to find the power series representation of natural log of 1 minus x. We have to find the power series representation of natural log of 1 minus x, so that we subtract it here. We subtract it here. So let's go ahead and we find the power series representation of natural log of 1 minus x. So that we'll add it, we'll subtract it to its counterpart. So we have a subtraction sign here. We have a subtraction sign according to the question. So for us to find, we need to differentiate this. So we are going to have negative 1 over 1 minus x. Now from here we'll have negative 1 x to the power what? To the power n. Now this is for this boy alone, because I wrote a is negative 1. I jot it down here. Then I just got this x to the power n. Now for us to move from here to here, we have to integrate. So our final, it will look like negative sigma infinity n equal to 0. When we integrate now, we are going to have x n plus 1 divided by the new power. Now we are subtracting this. We are going to take this and put it here. Now see, there's a negative sign. So this negative and that negative will turn into positive. So what we'll have as our final function is negative x infinite n equal to 0, negative 1 to the power n, x to the power n plus 1 divided by n plus 1 plus infinite n equal to 0, negative 1 to the power n, x n plus 1 divided by n plus 1. Then this will also be what? Positive. Infinite n equal to 0. We are just writing what we have already found. Now, ladies and gentlemen, we have found for the first part. For the first part of the natural log, of the question of the natural log, we have found. Now we just have to find some terms here. We just have to find at least 3 terms for this, 3 terms for this, and 3 terms for this. So we're going to be substituting. When n is equals to 0, so here I'll have negative x multiplying. So I'll ask myself, when n is equals to 0, here I'm going to have what? A positive. Negative 1 to the power 0 is a positive. Here I'm going to have just an x. When n is equals to 1, it will turn this into a negative. Then this will be x to the power 2 divided by 2. When n is equals to 2, I'll have a positive. Then I'll have x to the power what? 2 plus 1, 3 divided by 3. Then I know that this will be negative. I'll just end from here. We agreed on 3 terms. Let's come on the second one. The second one, when n is equals to 0, this will be 0. So we are going to have what? We're going to have an x. So this will be x. This will be x. Then when n is equals to 1, we are moving to 1. This will be negative there. X to the power 2 divided by 2. When n is equals to 2, this will be positive. 3 divided by 3, then less. We are ending here. Then I'm going to say positive for this guy. When n is equals to 0, we have x. When n is equals to 1, we have x squared divided by 2. When n is equals to what? N is equals to 2, we have x to the power 3 divided by 3. Then we're going to say plus. We are ending from here. Now we have to see. We have to match what we have. Now if you look at this, you can see that this guy and this guy, they will go. Since that's a positive, this is a negative, a positive. So this and that will go, will cancel out. This and that will cancel out. This and this, we see that they will add. But now let's expand with this. These two no longer there. with these two no longer there. Now let's start by multiplying. This we are going to have negative x squared plus x cubed divided by 2. Negative x multiplied by this, that's why it's negative, positive, this is positive x cubed. Then the one that is following is negative x to the power 4th divided by what? Divided by 3. I'll end it from here. Then let's write what we have here plus. This will be x plus x cubed divided by what? Divided by 3. This is what we have. This is what we have for this guy. Then let's say plus. But we know that this is continuing. We've just picked out those terms. We have x plus x cubed divided by 3. Now let's check out. Let's just find out those which are going to cancel and those which are not going to cancel. Now, if we look at this plus that, it will be what? 2x. This plus that, it is 1 over 3 plus 1 over 3. To be 1 over 3 plus 1 over 3. So our final term will look like this. We have this stands out alone, x to the power 2. Then this plus that, it is what? This plus that, we're going to have it's x with a degree of 1. So this is 2x. So it's the one which is supposed to start. Then we're moving to x with a degree of 3. 1 over 2. Let's just get our calculator. We have 1 over 2 plus 1 over 3 plus 1 over 3 again, which is 7 over 6. So this will be plus 7 over 6 x cubed. Then I'll just leave that one. It's negligible. Which we have is what we have is enough. Whatever we have is enough. Now we have to compare. We have to see. We have to check out what the question was asking us about. So the question said as the limit of x approaches what? X approaches 0. So we see that this term will be 0, this will be 0, this will be 0. All the terms that are going to follow will be 0. So for the first part of the question, we have seen that we have obtained what? We have obtained a 0. From the first part of the question, we have obtained a 0. So let's go for the second part of the question. So it's 0 plus the second part of the question which we are doing. So which was sin x less sin x over x to the power 3. So from here, you just have to know the power series for this and the power series for this. So what is the power series for sine of x? What is the power series for sine of x? So the power series for sine of x, it is, we just say less. The power series of sine of x is negative 1 to the power n, x to the power 2n plus 1 divided by 2n plus 1 factorial. Now the power series for this is just the power series of sine, but without the alternating negative 1 to the power n. So it's just these two. So we're just going to write this here, which is x to the power 2n plus 1 divided by 2n plus 1 factorial. Then all of this, it is over what? X to the power 3. Now let's get some few terms for this. We know that this is n equal to 0. This is the same n equal to 0, infinite. Now let's get 3 terms for this and 3 terms for this. So for sin, the first term we are going to have is x plus x cubed less x factorial 3 factorial plus this is going to be x to the power 5 divided by 5 factorial, then plus. So I've just substituted when x is equal to 0, we are getting this. X equal to 1, n equal to 1, we have this. N equal to 2, we have this. So this is for n equal to 0. So we have to find the same for this. have to find the same for this. When n is equals to 0 for this function, we are going to get x. But when n is equals to 1, we are going to get negative x to the power 3 divided by 3 factorial. Then we are going to have plus x to the power 5 factorial. Then this is going to be negative going all the way. Now, we can see that this will be x minus x. So, the first terms will go. For this, it will be x minus minus. So, this will add, but this is 5 x to the power 5 minus x to the power 5. So, this will also go. So, what we are remaining with is x to the power 3 divided by 3 factorial plus x to the power 3 divided by what? 3 factorial. So, this will be, we know that 3 factorial is the same as 6. So, the question is what is 1 over 6 plus 1 over 6? So, we're going to have x cubed divided by 6 plus x cubed divided by 6. So, this is the same as x cubed divided by what? Divided by 3. 1 over 6 plus 1 over 6 is this. Now, someone might come and ask you to say, the next term, which will be x to the power 6, x to the power, let's try, this was 1, 2, 3. So when we put 0, 1, 2. So when we put n equal to 3, this is going to be 2 multiplied by 3, that's 6, x to the power 7. Someone might say that we are going to have x to the power 7 as well. So it will be x to the power 7 plus x to the power 7 with over 7. So the term which was going to follow was going to be x to the power 7 over 7 factorial plus x to the power 7 over 7 factorial. I would want to show you something with this. We'll come to it a little bit early. So now let's focus on this. This is what we have, but look, our function was being divided by x to the power 3. So this divided by x to the power 3, we are going to get 1 over 3. So 1 over 3 plus 0. 0 of the first part of the question plus 1 over 3 is going to be what? 1 over 3. So the limit is equivalent to what? To 1 over 3. Now, let's come here where I wanted to show you something. This plus this, yes, we are going to have x. Now, but ask yourself, x to the power 7 divided by x to the power 3. You're going to have x to the power 4. Now, as the limit of n approaches to 0, these all terms will be 0. So all the higher degrees of x which are coming after this one will all go to 0 as well. They are just going to be going to 0 to 0, since they have a higher degree than the one which is dividing. Friends, thank you for watching, and if you haven't yet subscribed to the channel, hit that bell icon so that you don't miss out on future endeavors. Bye bye.